This is Mr. Ward, and I'm going to walk you through my thought process as I create a magic trick. So I'm going to start off by saying pick a number. Pick a number. We'll graph that. We'll algebraically call that number x because it's an unknown. Now, I'm going to tell people to do something to that number. Maybe I'll have them add something or multiply or divide or subtract. I'm going to avoid division because I don't want them to go to a fraction right away. So I'm going to try and prevent them from going to a fraction. So instead, let's add something. So let's say add 17. Okay, and now we're going to have that expressed as x plus 17. And if I zoom out on this graph, you'll see a parallel line to this original just y equals x line, which is what that is. Every y value equals every x value. Now, every y value is 17 more than every x value. At any rate, I added 17. Let's do a next thing. A next thing might be, let's multiply. Since I've added, I'm going to switch to a more complex operation. Let's multiply, spell it right, by 2. We're going to multiply by 2, and then we're going to end up with 2 times this expression, x plus 17. But I'm going to go ahead and simplify that and call that 2x plus 2 times 17, which is 34. Okay, and those are just two versions of the same thing. This second version, the simple version, will help me keep track of the things I'm doing. I know for sure this is an even number, as long as they picked a whole number to begin with, or really any integer, 0, any counting number, or any of the negative counting numbers. Right now, we're going to do the next thing. Now, the next thing, I'm going to do something to this 34 to make it just a little easier to work with. I'm going to subtract 30. Okay, and that's going to leave me with this. So Control A for select all, Control C for copy, and then go down to this cell and say Control V, okay, for paste. And I'm going to say minus 30. Okay, now I'm not going to do this minus 30 using that. I'm going to do it with this. So minus 30 with a simple version, and 34 minus 30. I can't really take a 30 away from 2x because those are not like terms, but 34 minus 30 is just 4. So now I have 2x plus 4 is a really simple situation, and I can do some other things now. I think since I multiplied, I will now divide. Okay, so I'm going to divide by 2. Let's divide by 2, and we'll end up with this big funky expression. Put parentheses at the end so it knows I'm dividing the whole thing. So that's a much fancier expression. I don't need those parentheses anymore. Okay, because the fraction bar does the job of parentheses. And I'll go down and actually do this operation on the simplified version. So divide by 2. So 2x plus 4 divided by 2 is just going to be x plus 2. Okay, so now we got something super simple, and I will let's go to a place. We're going to try and make this equal 11. So I'm going to say add 9, right? That's what I really meant to say. Okay, so I'll go ahead and copy the fancy expression here. I'm going to add 9, but I'm really going to do the operation using the simple expression, plus 9, and that's going to be x plus 11. Now, I'm going to get rid of my original number, and I'll end up with 11. So take away original number, and the fancy way of looking at it is this, minus x, and then the simple way of looking at it is this. Control A, Control C, Control V, minus x, and I end up with just 11, and that's where I ended up on this. And you might notice that we end up with a horizontal line where all the y values, no matter what original number, whatever x was, we end up at 11. All right, I hope that was helpful to you, and I will stop this video.